Bulgaria just rewrote the rules of prostate cancer care, and hardly anyone noticed. That headline might sound like clickbait, but the numbers are real. More than 200 men with late-stage prostate cancer, a price tag that would make most hospital accountants sweat, and a level of genetic detail that even some Western European centers have yet to match. But here's where it gets controversial. The study suggests that two patients who both test positive for HRD, the shorthand for a DNA repair defect, can still have wildly different responses to the same targeted pill. In other words, the label on the bottle may be identical, but the biology inside the tumor is anything but. Let's unpack what actually happened. A dream team of white coats, oncologists, urologists, geneticists, pathologists, and the unsung heroes known as bioinformaticians, spent months inside Queen Joanna ICUL Hospital in Sofia. Their weapon of choice was next-generation sequencing, NGS, the Ferrari of DNA scanners. While most registry trials abroad lump patients together under broad genetic umbrellas, this Bulgarian crew zoomed in on single-letter changes, insertions, deletions, and even the sneaky copy number shifts that older tests often miss. The goal? To see whether modern PARP inhibitors, those headline-grabbing drugs that lock down a cancer cell's ability to repair its own DNA, work the same way in every genetically eligible patient. Spoiler, they don't. Dr. Georgy Dimitrov, the oncologist steering the ship, puts it bluntly. We proved that not all HRD mutations are created equal. Some behave like effectors. They practically roll out the red carpet for PARP inhibitors and the tumor melts away. Others act more like sensors. They set off the same alarm bells in the lab report, yet the drug barely flinches. Imagine two men, both 67, both with rising PSA and scans lighting up like Christmas trees. Their genomic reports both say HRD positive. Patient A has an effector-type BRCA2 mutation. Within weeks, his PSA plummets and the bone lesions fade on imaging. Patient B carries a sensor-type alteration in a lesser-known gene. The same pill does little more than give him nausea. Same drug, same country, same study. Utterly different destinies. Dr. Alenko Popov, the urologist who co-led the effort, beams with national pride. Bulgaria is often portrayed as a place where high-tech medicine arrives 5 years late. This study flips that narrative. We didn't just import the technology. We mastered it, adapted it, and produced data strong enough for a first-quartile oncology journal. That journal, Clinical Genitourinary Cancer, is published out of New York by Elsevier. Landing a paper there is the academic equivalent of scoring a table at a Michelin star restaurant. Possible, but never easy. And this is the part most people miss. The implications stretch far beyond prostate cancer. If effector versus sensor distinctions hold true in ovarian, breast, or pancreatic tumors, today's one-size-fits-all companion diagnostics could soon look as outdated as dial-up internet. So, dear reader, here's the provocation. Should regulatory agencies start demanding subclassification of HRD before approving PARP inhibitors for any new cancer type? Or would that fracture an already fragile access landscape, leaving patients in smaller health systems behind? Drop your thoughts below. Agreement, outrage, or somewhere in between. The debate is wide open, and your voice might shape the next clinical guideline.